Start with the 29th example. A wire forming a loop is dipped in a soap solution and taken out so that the film of soap solution is being formed. So here is the frame on which a film of soap solution is being formed. Now what is the said here? A loop of 6.28 centimeter long thread is gently put on the film. So here the loop is gently just put on the film, so that on the outer surface and as well as on the inner surface there is a force of surface tension. The thread loop, now the film is pricked with a needle inside the loop. Okay, so with the help of needle, the inside the loop the film is pricked, it is broken. So it is but obvious due to the surface tension force on the outer circumference of the loop, the wire will get stretched and it will take a circular shape of certain radius. And we need to find the tension in the thread. So if we take the small element, of this thread, say which is subtending, its radius is r and it is subtending an angle d theta. So we need to find this tension here like this. And we know that on this small element the force due to surface tension would be equal to surface tension into perimeter of this loop, which is arc length, radius into d theta. And after resolving tension developed in the loop into two parts, these two parts like this. So this angle would be d theta by 2, d theta by 2. So this angle is d theta by 2. So this will be sine t into sine d theta by 2, t into sine d theta by 2, where t is the tension. So after seeing the equilibrium of that particular loop, we can conclude that t into sine d theta by 2, these are the two forces which are acting downward. They are balancing the force of surface tension into r, surface tension into the arc length, that is r into d theta. As this angle is very small, so we can write sine d theta by 2 as approximately sine theta d theta by 2 can be written as sine d theta by 2 can be written as d theta by 2 now, because when angle is small, sine theta would be approximately equal to theta. So on this side d theta and d theta cancel, these two get cancelled. So tension in the loop would be surface tension into radius. As surface tension is 0.03 and radius is not known to us, the length of the thread is given. 6.28 centimeter is the length of thread, which would be 2 pi r. So radius would be equal to 6.28 upon 2 pi, but this is in centimeter. So 6.28 upon 2 pi centimeter, so they convert this into meter. We know that 2 pi is nothing but 6.8, so this will cancel. The tension in the loop would be 3 into 10 to the power minus 4 Newton, and that is the answer to this question. Thank you.